Hey everybody, welcome back to Deterministic. I'm Brandon Konkle, and I'm really glad to be able to get back to my series on Nest.js that I've been working through. The last few weeks have been pretty chaotic for me. I've had some family medical trouble, and it's been a little bit scary, but thankfully we're on the other side of things now. Everyone's starting to feel better and recovering well. And I'm glad to be able to get back to my series and get back to sharing the strategies that work well for me with Node, TypeScript, and the Nest.js framework. So today I'm going to talk about effective testing with Nest.js. And this is something I feel really passionate about. I think testing is something that often gets neglected, especially during the early phase of a project or when you're in the prototyping phase of a project. But I would contend that's actually when it's most important, when you're actually laying down the foundations of things. You're giving yourself a roadmap or a guide on how to make changes later, because you're going to make a lot of changes, especially at the early stage of a project. And so kind of similarly to type safety, testing gives you guardrails and helps you kind of encode some of your expectations and some assumptions in a way that you can check them even as you're making changes to your code. So one of the things I talked about in type safety was the real value that you get when you go to refactor. When you're making changes, type safety, TypeScript can help show you all the other places that your change impacts. Because often when you change something in a complicated system, there's impacts that are hidden that you don't see in other files in completely different places that had expectations around how the code worked at first, but it's changed. So type safety points out, okay, this property is supposed to be this type, but that's changed, or this property is over here now, or it's gone, or it's a totally different name for the property or different arguments for the method, all of that kind of stuff. But that still leaves a pretty huge gap in testing your expectations and assumptions when it comes to the actual business logic, the work that you're trying to get your code to do. A lot of people who use really strictly sound languages, thinking around the Haskell space or something like that, they often argue that especially unit testing isn't really valuable because the type system helps you. But I would contend that there's a lot that the type system can miss about how you intend your code to be used. So I think unit testing can be really valuable as an example of all the different ways that you expect your method or your isolated unit of functionality to be used. And it also allows you to exercise the type system and make sure that the assumptions that you're making, they play out long term, that they're practical and they actually work when you're realistically trying to get your project to do things. And then integration testing steps back a little bit and allows you to test multiple things together and see if things fit together the way that you expect them to during a particular flow, for example. And then you've got end-to-end testing, which we won't really go into much detail about on this video because that's a whole different ballgame. It's a whole different subject. You've got tools like Cypress and the old classic Selenium that have a lot of different intricacies around working with them and quirks. And since our application is in purely a back-end API, we're assuming that somebody else is developing the front end that will connect to this, or the mobile app, or what have you. So we don't really have everything we need for a real end-to-end flow. So before I go any further, let's go ahead and dive in a little bit more about what 3 of the most common testing strategies are. There's more strategies than just this, but these are the ones that you'll really commonly see in web software projects. So starting off, I've already mentioned them: unit testing, end-to-end testing, and integration testing. So let's look at unit testing first. That's when you take really small isolated pieces of functionality, usually like an individual function or an individual method, and testing them completely on their own. So anything outside the function itself, including inputs and injected services, they're mocked, preferably in a way that can be easily inspected. You can pre-program behavior in your mocks so that those interactions with other functions can be isolated down. You can eliminate those as a possible point of failure because you're pre-programming the mock to give you exactly what you expect there. And it's that unit of functionality inside the function or the method that you're targeting here. And Jest and Mocha are really popular tools for this in the JavaScript ecosystem. But Nest.js provides an additional layer with its dependency injection system. And this is something that's commonly misunderstood, I think, especially when you see people who are really used to dynamic languages like Python and JavaScript and vanilla Node, that they don't necessarily see the value of dependency injection, but after fighting with Jest's auto mocks or their manual mock system or trying to rewire imports and things like that, often they'll see how frustrating that can be. You can have a situation trying to get Jest to auto mock some module that's imported by another module and then imported by another module beyond that, and like sorting out where those imports happen and how to rewire them within Jest can be really tricky and complicated, and you don't have any kind of type system guidance to help you there. So that's where the dependency injection system steps in. That's one of the primary goals of the dependency injection system, is to make things more easily testable in ways that you can substitute parts of the application in where you need to. And then another thing that the dependency injection system does is help you bootstrap the application when you start up, so that all of your controllers and your services and things like that are registered the way that you want them to be, and you have some control around how those are initialized once the project starts up. But that's one of the ways that we can ideally avoid Jest mocking entirely. If you've got a really solid system like Nest's dependency injection, you don't have to worry about rewiring imports at all. You can just use the test dependency container to register just what you want to and substitute mocks for things that you want to really easily. It gives you a lot of control. So next, let's go to the opposite end of the spectrum, end-to-end testing. So this usually involves scripting or automating a front-end application. So a front-end could be a web page, it could be a mobile application, it could be a Roku app that plays on your TV, it could be anything like that. And you want it to script that in a way that it's used realistically. You're automating how you expect your users to interact with your application. And then you're following that through all the way to the API calls, the database, and then the data that comes back and gets returned. You're checking end to end if everything is fitting together the way that you expect it to. And so typically with end-to-end testing, you're going to cover your critical flows. You're not going to get 100% coverage on end-to-end testing because it's time consuming and it's really a system of diminishing returns. But if you're focused on your critical flows, the things that absolutely have to work, usually you can get a lot of value out of end-to-end testing, especially during continuous integration pipelines and things like that can run these things behind the scenes for every single commit and make sure that you're not breaking something you didn't intend. Cypress and Selenium, like I mentioned, are really popular tools for this in the web development ecosystem. There are tools in the React Native space and really in native development in general. And I think I've got those on a slide later on. I can't remember the names of them right now, but there are tools out there for mobile apps and desktop apps as well. But beyond that, the other piece that I'll be focusing more on is integration testing. That's kind of fits in between end-to-end testing and unit testing. So unit testing is just individual functions, little tiny pieces of functionality where you can isolate everything else. End-to-end testing is everything all together from beginning to end, and integration testing is putting some of those pieces together to test in more realistic circumstances. But for the example of our API caster app that we're working on right now for this project, we don't have a front end. We don't have an end-to-end option, but we can still get almost all the benefits out of that with some really good integration testing that starts with the HTTP request and goes all the way out to the database and back. And it also gives you a chance to mock really pricey or really time-consuming dependencies. If you're making calls out to other services or other APIs and you don't necessarily know if they'll be up, or you're paying per call or something like that, integration testing allows you to swap in mocks for those things, but try to keep as many things put together as you can. You get to decide where the boundaries are. So Nest.js has some pretty strong tools for unit testing and integration testing, but when you get to end-to-end testing, that's when you need to reach for other tools like Cypress or something like that. All right, so let's zoom in a little bit on unit testing and talk about how I have all of that wired in for my demo project. You can find the link to the GitHub project in the show notes. It's pretty easy to set up. Go ahead and follow the README if you haven't already. And once you get to the point where you've run all the database migrations, you've generated your Prisma client, and you've run the code gen script to generate all the GraphQL code generator schema stuff, which we make use of in the integration tests, you should be ready to go ahead and fire it up and give it a try. So I'm going to pull up my screen here and share my project. So yeah, let's go ahead and zoom all the way into this. All right, so this is the Nest.js or the Castor Nest.js project. Like I said, I've got it linked out on the in the show notes, but let's go ahead and pull up some of the libs here. So I'm not going to pull up the main app. The main app is where I have the integration tests. We'll come back to that in a moment. But for right now, I'm going to pull up the libs and look at, let's start out with the users, because that user, what is it? The user resolver doesn't do a whole lot. So let's pull up the user resolver and just review really quick. This has a few different operations defined in the resolver here. You've got get current user that uses this request user decorator to pull the user out of the JWT token based on the sub, and we covered that on the last video on authentication and authorization. There's get or create current user, which will create it if it doesn't exist. That's really useful for limiting or cutting down on the number of calls that the front end is making and allowing them to do more things in one call. And then I've got an update current user method that requires the user to be logged in. So to test, and you see that in each case here, except for where it's just using the decorators, in these cases down here, it's using the service underlying. There's a user service that the user resolver communicates with. So you can think of resolvers in the GraphQL space really similarly to controllers in the REST space. A request comes in and it gets mapped to a resolver, which is like a controller, to handle the request and translate it to terms that the service on the inner layer understands. And the service is kept agnostic. It's kept idiomatic in the TypeScript kind of structure so that any kind of entry point can use it. So if we wanted to add a REST controller that would then use this same user service, we can. This layer of separation allows the resolver or the controller to kind of map the request to an inner service that will be able to handle it. So in our case here, we've got this user service, but before I move on to that, first I'm going to pull up the user resolver tests here. So this will demonstrate actually injecting that service, because we don't want to test that service itself. We want to test the user resolver in isolation. We want to say, okay, let's assume the service is doing what it should. We'll test that separately, and let's just focus on what the resolver itself is doing and make sure that all the logic that we've got encoded in there is working the way that we expect it to. And like I said, it's a good way to kind of exercise your types. It's a good way to use your code in the way that you intend it to be used and make sure that there's no unexpected type issues or things like that, which actually are a thing that come up quite a bit. So in my users resolver here, you see I'm doing a couple of things up here. Let me come back to those things in just a moment. Let's start with the before all hook here. I've seen some people do before each so that it's reset between every test, but since I keep things stateless, I don't save any state on the instance of the resolver itself, I can initialize my module once and reuse it between all the tests so that things go a whole lot faster. And then I just make sure to reset my mocks in between each test so that all of the pre-programmed behavior that I had for each particular case goes back to normal. So in this before all hook here, this runs before all of the other things in this block. So all the describes, all the its inside there, this before all runs first. And it uses Jest's create testing module function. So this creates a test dependency injection container, which means that it initializes things it initializes things the way that we ask for them. So for instance, my user service here, I'm telling it provide the user service and just use this value. And so I'm going to come up here and see what the value of service is. And oh, hey, it's this mock deep function. So you can see I'm injecting the user service as a mock. I'm doing the same thing with the ability factory. I'm injecting that as a mock. But then the user resolver itself, I'm allowing that to fully initialize like it would in production. So that's saying that, okay, these dependencies here, this user service, this ability factory, those can be mocked, but let's keep the resolver whole so that we can check that it's working the way that we expect it to. This mock deep utility here, this comes from a great library that I've used for a while now called Jest mock extended. And this gives you kind of superpowers, especially when working with TypeScript, to mock things automatically without even having to think about it. And so that's what I'm doing here. I've got my service, I've got my ability factory, and I've got the ability that the factory should generate here, all as automatic mocks where I'm passing in the type that they're supposed to mimic. And the really cool thing about that is that they really do descend into the type and wrap around everything in a way that it can let you know, hey, you're using this mock wrong. It can tell you, hey, this mock is not supposed to return what you're having it return. And that can be annoying at times, but it also helps you refactor your tests when you make changes to the actual production code and not have to guess at, okay, let's run these tests and why did these tests fail? You'll see right up front that, oh, I'm returning something that it's not supposed to return anymore. I need to update that test. So you saw down here in this Nest create testing module, we've got a user resolver that we are providing that instantiates in the normal way, the same way that it's going to happen in production. And then to pull that out, you see I've got a let declaration up here so that I can reassign it. And I do. Inside this before all hook, I reassign resolver to whatever test module.get returns. So it's going to return the instance of the user's resolver that it was able to instantiate with all of the dependencies provided within that test container there. So I've got a real resolver with fake dependencies. So the first thing I'm going to do is test get current user. And so I use a describe block and then an it block to kind of behaviorally describe what we're checking with this test. So this get current user uses the request user decorator to find the user by username. And this is a really easy test because decorators, the way that Nest attaches decorators makes it really easy to test this way. If you go back to the user resolver itself, right here you've got the username decorator and the request decorator. This decorator right here is just to make sure that a JWT token is present, and if that JWT token, the username matches up to the sub in the token payload claims, so many fun terms there. If there's no JWT token, then this is just going to return a 401. Then the user itself, though, that's optional because it's possible that the user has logged in with the JWT token, but they don't actually have a user in the database based on that sub or that username property. So this is where we're actually trying to retrieve that. It's optional. You can see that it's got a question mark after it, which means it can be undefined. You can change that. You can use the require true flag here, and that's a feature of the decorator like we covered in the last video. But in this case, we don't want that. So you can see here, all we have to do to actually mock those is pass them in. We pass in our fake user that we've created here. Where did that come from? Oh yeah, where did this user come from? Oh, it's up here. There it is. Yes, I have a user factory that's defining that. And I'm casting it as a slightly different type that has this optional profile on it. That's just a quirk of my models as I have them set up. But I'll dive into this factory in a moment. But basically, this is a fake user. It's a mock user, essentially. And I'm just passing it in and then making sure that that's what gets returned. So I'm saying, yes, this second argument of the function or the method, that's what I want to return. That's what we're seeing in the code here. And so if anything changes, then this will start to fail. The way that Nest handles actually attaching this is When Nest calls the resolver, it is using its build tooling to read in all the decorators here and to determine, okay, what should I actually pass as this parameter? So that's how Nest works. It wraps all of this pre-programmed functionality when you've got everything stitched together. This is something that you exercise during the integration tests, but on the unit tests, you get a free pass. It's really easy to work with that way. So let's go on down to the get or create current user one. This one uses the decorator to get a user if one is found, and then I've got another test that says to create a user if none is found. So in the first case, we're going to set up some input here. You can see there's args input that is this create user input class. I'll go into what those look like in a moment too. But I'm creating that input, then I'm passing the input in along with these decorated parameters, the same parameters I had last time, username and request user. Those get passed in too, and then I'm looking at the result, and I'm checking to make sure that first, our mocked service wasn't called. So this is the first place we're making use of some of that automatically mocked behavior. You can see service is this mock wrapper around what the service is supposed to do based on its interface. The create method here is supposed to return, or supposed to be a promise for a user. So you can see here we're checking with some of these Jest assertions to make sure that it is not, that it hasn't been called, that it didn't try to create a user. So, and then next we're checking to make sure that the return value actually included the user that already existed. So this is happening because we're passing user in here. The decorator got a truthy value. It got something rather than nothing. So that's this parameter here. So since we passed it in, service.create shouldn't be called, and the result should be the user that we passed in as the decorator parameter. So that works. And then we've got the same test, but this time we're not passing in the user. We're passing in the username. That's one of the decorated properties, but we're leaving the user off of the end there, leaving it blank. And so in that case, we should expect that service create is called one time. I always like to assert the number of times something is called because it's actually pulled up a number of bugs where we didn't expect things to be called multiple times, and we figured out why, and that solved a problem. And then you make sure that it was called with the input that you expect. So you'll notice that I'm not retesting the same thing that I tested in this previous case. I'm not checking that result equaled user because I've already checked that in the previous case. So update current user is the last one here, and this is a little bit different. It requires a user. You can see in here request user is required. So we don't have a case where we're not passing the user in, but we are passing our input in. We're changing the isActive flag to false in this operation. So we're checking to make sure, okay, was the update method on service actually called, and was it called with what we expect it to be called? So overall, you can see how the flow works. We're mocking that service, but we're doing it in a way that we don't have to mess with the Jest automatic mocking system or rewiring the imports or anything like that, which often has a lot of unintended consequences and doesn't work the way that you expect it to. We're using this Nest structure to inject what we need really easily and in a very type-safe way. So if this user didn't match what the update method was supposed to return, you would get a type error here, and you would know, okay, it's time to fix this test or change this test to account for something that's changed in the code itself. So backtracking a little bit, let's look at the factory first. So this factory I have defined down here in my test/factories directory. I've got factories in each of my lib modules, the domain-based groupings that I've talked about before. So you can see an episode and a show factory here in the shows lib, and in the users lib, we've got the profile and user factory here. And so the user factory itself is pretty simple. I separate it into two things. I have make create input. So this is going to match that type that I was talking about before, this class create user input. So let's pull up that really quick. We went through these during the video talking about GraphQL schema and setting up resolvers and everything. But this is the input that's needed to create a user as opposed to updating a user. And this is creating a user with a profile, or I'm sorry, creating a profile in line with the user. But in any case, this user factory allows you to pass in overrides. So it could be a partial object that matches the create user input, but we omit the profile property for type system reasons. Otherwise, there's a type error that's tricky to work around. And then we spread those overrides in with the spread operator, and then we use Faker, which is a great library for generating random test data. We use that to generate a random username there. And so then I've also got make. So there's make create input and make. And so make actually calls make create input to pull in that username property that we've already created a faker for. So we don't need to recreate that. And then it spreads in the overrides. But before that, it provides defaults for the ID, created at, updated at, the isActive flag, the things that we don't need on creation, but that we might want to update or test later. So the profile factory works exactly the same way. You'll see that in the other factories as well. They're easy to make, easy to use, and it keeps you from creating big JSON blobs of data in each test to set up redundant test data. So, all right. So, and you'll also see here, I've got kind of a global mock here. This is a mock that will continue to behave this way even across multiple tests. No, actually, I'm wrong. So I've noticed a bug here already. So this ability can mock return value. That should return true every time, even after clearing the mocks. But the oversight in my test here is that when you reset mocks as opposed to clearing them, that actually resets all of the pre-programmed behavior. So I have this pre-programmed ability can that I'm mocking to true, but then I'm wiping it out after each test. So that never gets added back. I will go ahead and change this now to clear all mocks. That's one tricky distinction I've run into with Jest between reset all mocks versus clear all mocks. If you have pre-programmed behavior that you want to persist between tests, something that should always return a certain way, then you can add this, you can use clear instead of reset. All right, so let's see. I think I covered everything that I needed to here. So let's go ahead and run this test to make sure that everything's working correctly. So I'm going to run nx run users test, and then I'm going to tell it the test file I want is users resolver. Whoops. That's going to fail because there's no S at the end of resolver. There, let's do it that way. Okay, found my specific test file. That way it's not running everything all together. And I can get some quick feedback about this test suite that I'm working on right now. And you see it ran through each of the points. It checks them off and it looks good. And it took about 11 seconds. That's not bad. All right, so the next one that I pull up will be the service test. I won't go quite as in-depth because it follows the same kind of pattern. But here is my service, my user service test. So let's pull up user service really quick and kind of reflect on what it does again. It takes input that is idiomatic TypeScript. So I generally avoid passing in like GraphQL input types or HTTP param types or things like that. These are the kind of types that make resolvers and controllers really easy to work with. But I want my service to be agnostic. I want it to work with anything that works within TypeScript so that if I have an entry point later that works in a completely different way, like WebSockets, for example, that I can still use the service the same way and I don't have to do anything special to convert input types from one format to another. It's all just TypeScript. So my user service has a get by username, a create, and an update method. And these all essentially are just wrappers around Prisma. So Prisma is that auto-generated database client that we've talked about in a previous video also. So this just wires in the things that we need to do what we want with our database access. You'll see I'll pull up the shows service that has a little bit more sophisticated code around getting multiple entities and kind of translating some of the offset or pagination properties that you would use there. But this one's more simple. This one's pretty straightforward. So for our user service test, it follows the same strategy. And in our previous one, since we mocked the service, we didn't have to worry about any of the service's dependencies. None of those particulars, we didn't care about that when we were testing the resolver. But here we are testing the service, and so now we need to mock the service's dependencies. And so now you're seeing me set up a mock for Prisma here, so that I think that's the only dependency, right? Yeah, this one just has the Prisma service as the injected dependency here. So that way we can make sure that we're using Prisma in the way that we expect to be using Prisma. This is more relevant in the things with pagination and stuff like that I was talking about. But it allows us to exercise that code and make sure everything's matching our expectations. And we don't have any pre-programmed behavior here that we want to persist between each. So reset all mocks is fine here. I generally default to clear all mocks. So I'm not sure why I went with reset in this case, because reset has that kind of surprising behavior, I think. But in any case, it can be useful in situations where you are setting up pre-programmed behavior that you forget about or that doesn't get invoked like you think that it should, and that'll clear the state for the next test that's coming along. But I generally just use it.only to isolate down to just that one test when I'm coming up with an issue like that. Anyway, so my describe blocks here line up with my methods, and then individual cases for each method are covered by it statements. And it follows that same kind of strategy. I set up my pre-programmed behavior for Prisma. I want the prisma.user.findFirst method to return a user. And then I call my service with the user ID that I generated with my user factory. And then I check to see, okay, so I called the service with the user ID. So was Prisma called with the user ID also? So Prisma, I'm checking to see if find first how many times it was called. It should only be called once. And it should be called with, and this is where I'm using a strategy to check partial values on an object. So I say expect an object containing these properties. So I only care about the where clause here. If we had, like up here, we've got this include profile. I don't really care to test that at the moment, so I don't expect that in my test. It's not critical for that to be there. So I'm just using expect.object containing to see that this where clause has the user ID that I passed in. And then I check to see if the result is the user that I pre-programmed Prisma to return from that operation. And it should. It is. You'll see the same flow with all of these tests down here. I'm testing different cases, different ways of calling it, making sure that I'm calling Prisma in the way that I expect. And this way, you can also, like I was saying about exercising types, you can see if the input that you're providing is accepted by your service function. You can see if Prisma ends up having changes and their types change or their signature changes. You should also see some problems here. And so this helps you keep everything fitting together well. So let's see, I've got one other major test type to cover, and this is the tests for my castle abilities. Now, I talked in the last video about how I have these rule enhancers. And so this rule, users rule, has a for user method that builds up some castle rules based on the user that was involved in the request. And so this makes sure that those rules behave the way that I expect them to. And this was really important. This actually helped discover a pretty critical bug in a recent project that would have been a big problem in production. So in my case here, I'm describing that for user method, and I'm going through and using an ability builder with my app ability. So this would be two utilities that come, or one utility that comes from Castle and one that's my app specific ability that's based on my Prisma entities. So I'm mocking those things, or no, I'm sorry, I'm using those things because I want to check that Castle builds things up the way that I expect. So in this case, the whole point of the test is we're checking to make sure we're using Castle right. So if I were to mock Castle in this case, it would completely sidestep the real point of the test of making sure that I'm using Castle correctly. So I violate strict isolation slightly here to pass in an actual ability builder based on the app's abilities, but it's just so that I can make sure that it's doing what I expect it to do. So I call rules.forUser with the user and the builder that I've instantiated, and then I create my ability with builder.build, which is what the ability decorator that we talked about in the last episode does. And then I can call all of these different things. Ability can. So can this user create a user object like this? And I expect it to be true. But let's say, can this user create a user object with the username of some other user? No, they can't. Our castle rules, so you can see right here, they only allow you to create a user with a username that matches the user's username. They can only create their own user. And so it goes through like that, checking to make sure that all of the assumptions work the way that we expect it to. All right, so you saw how to use NX to run tests from a specific lib using that test file flag. But what if you want to run everything all together? That's where I have the yarn test function or command script. It's a script, the yarn test script. And so what this does is it uses NX run mini to test everything all at once. And so that's generally what you want in a CI process or something like that. So if I just run yarn test, it's going to run through tests for all of those projects. And I just ran it a little bit ago and everything passed. So it better pass now. And it'll take a little bit of time to run through that. But hopefully this helps show how you can isolate your units and mock things pretty easily in a type-safe way, where the type system is still helping you keep things up to date and kind of being your ally through the testing process. And another advantage of unit testing that I haven't mentioned yet is also just the level of documentation that it provides to people behind you. You leave a lot of clues behind for whoever picks up the torch behind you. Things like your actual project documentation, but sometimes that falls out of sync. Things like your inline method documentation, and then the tests are another thing too, where you're demonstrating all the ways that you intend your code to be used and the expectations that you have out of that, of all the different permutations of everything. It's a really valuable thing, not only for refactoring, like I mentioned, and making changes, but also for the team coming behind you to know what's up and how it's supposed to be used. All right, so that's unit testing with Jest or with Nest, and using the dependency injection system to your advantage. So stepping back a little bit, let's go into integration testing. So I've said before that I find integration testing to actually be the more valuable of the two compared to unit testing. And that's because you're fitting a bunch of pieces together and testing it in a more realistic fashion. It may not be all out end-to-end testing where you're including the whole front-end app, but it's really valuable because it's often a whole lot easier to work with than Cypress or Selenium or some of the end-to-end testing tools out there. So it's definitely an important piece of the stack. It's the stack that I often start with when I'm doing something greenfield, when I'm creating a whole new controller or a whole new service or something like that. I'll often set up my entry points first and then get an integration testing loop going so that everything is being put together and I'm checking that everything is working like I think it does as I'm iterating on it. And then once I settle into, okay, this is the inner API that I want. This is how I want to set it up for other developers to work with it or for me to work with it in the future. That's when I'll bring in the unit testing to make sure all the bases are covered and all the different branches of code are covered. I don't typically go for 100% coverage on unit testing because that starts to get into faking the system out or testing things that aren't really reasonable just so that you can exercise this particular code path that you don't ever actually expect to hit. You can be pragmatic with it. You can test the things that are valuable to you without going, completely overboard. Like I was saying, it's a system of diminishing returns, and the closer you get to 100%, the less valuable the tests you're writing are, at least in my experience. But with integration testing, that is something where I do try to get not 100% code coverage with all the branches and everything, but I do try to cover all the use cases. everything that I want my code to be able to do, I'm going to test with an integration test somehow. It might be included with a couple of other pieces of functionality and checking the database to make sure that it's working the way that we want. But included as part of this flow that I'm testing, I want everything that can be done in that flow to be exercised by the integration tests. So my strategy for integration testing, I've seen some people use Cypress for this, especially in the NX community. I've seen Cypress used even for just, API calls, but it's a hassle to set up, and you can't use a lot of the standard tools that you're used to using. And with Cypress especially, you have to get used to its async concurrency model, which is not very, it doesn't line up well with the async await kind of style that we're used to now in modern TypeScript. And so it's kind of awkward to work with. I like using built-in tools like Jest and supertest to make it easier to work with my integration testing and just be able to kick it off from the CLI really quickly and not have to spin up like a fake automated browser environment. So Jest with supertest is the recommended approach with Nest.js. And you'll see a lot of examples of other projects using it. And I have some tooling around GraphQL that makes things a little bit easier to work with also in my integration testing. Nope, wrong screen. Which display? I was wanting to share this display. There we go. All right. So back to the project. Let's pull up those tests that I had skipped earlier. Those tests in the app folder. So let me close these out. All right, here's apps and here's tests. Now, these live at the top level because they require the app to work. These are integration tests that actually issue an HTTP request, and so the app structure needs to be in place in order to resolve those requests to the actual resolver method or controller method if you've got a REST endpoint. And it actually hooks in all of those decorators and it plugs in all of that middleware functionality that Nest.js uses. And so that's why in my project they live under the app, because the app is inherently necessary in order to test the integration at the level that I want to. So once again, I'll pull up the users integration test, or once again, I'll focus on users, but I'll pull up the integration test here. I've got users.integration instead of users.test. And the way that I target that is in my tsconfig here. This is one thing. I've got .integration included in my tsconfig.test.json. But then I also have a Jest integration config here that tells it, okay, look for the tests that are .integration.ts as opposed to the default of looking for the ones that are .test.ts. So going back to my integration test here, you can see I'm actually pulling in, let's see. Oh, I've got a couple of test tools here that I'm pulling in. So first off, I'm setting a reference to the app at the top level so that we can reuse that app that gets initialized each time. And then I'm setting up some helper functions here. There are a lot of times when you need to set up some prerequisite data, some data ahead of time before you actually run the test. And so I like to create some helpers for that to make that easier to work with and not make you issue an HTTP request each time, or in our case, insert data with Prisma. But I'm also using this OAuth2 helper. So this comes from Castor utils test OAuth2, and it's MIT licensed open source. You're free to steal it and do what you want with it. So that has an init method here that sets up a before all hook that establishes all that you need to actually interact with your identity service to get tokens during testing. In my case, I'm using Auth0, which it's one of the most usable services out there, but is also one of the more expensive services out there. Larger projects may want to consider something else, but for smaller projects, Auth0 is amazing, and it's great for larger projects if you have the budget too. But essentially here, I'm using my config helper. You can see I'm allowing an override config to be passed in if you want. In my case, I'm not, though. I'm just using the default config. I think in most cases you'd want to use the default, but I put that there just in case you want to override it for a particular test or suite or something like that. But then this sets up, using the environment variables, it sets up all of the params that you need to call your identity service with in order to get a token for testing. So, for example, I'm using the password grant type. My username and password come from the config, which ultimately comes from the environment variables. The client and ID and client secret also come from the environment variables. I've got my scopes in here and the audience that comes from the environment variables as well. And I'm doing two different things. I've got credentials and alt credentials, because mainly my tests are around the primary user and some other user. So can the primary user do what he's authorized to do, and is the some other user blocked from doing what they're not authorized to do? So that's what all this does. It goes through and sets up all of the test credentials before the test ever runs, and then exposes a reference to them as the return value of this OAuth init method. So in this particular case, I'm only using the credentials of the primary user. You'll see in some of my other integration tests, though, where I'm using the alt credentials to check authorization. And then I'm actually spinning up a real live Prisma service here. So this comes from the Nest.js Prisma library. I'm doing this so that I can set up test data. And then there are also cases where sometimes I've needed to check data in the database to make sure maybe it's not specifically or explicitly part of the return value, but it's something that I still want to check to make sure it ended up in the database the way that I expect it to. So I generate a nice real live Prisma service at the top level for use within my utility functions here or in the tests themselves. So then you get to the initialization code, our before all block here. I'm clearing out the database of any users that exist so that I can start with a clean slate. That's a really good thing to do when you can. I have been on projects, though, where that actually slows things down quite a bit, and it's actually better to leave some data in the database between tests if you need to. So your mileage may vary there, but in my case, I'm actually using this create testing module, which is the same thing that I'm using in the integration tests, but I'm not injecting a bunch of mocks. I'm actually just importing the app module, and this is the same app module that the main.ts file loads, and compiling that so that I can then pull the actual application out and then initialize it. You can see down there, I can add my validation pipe in so that it's working, the same way that it works when you boot the application up in production. So this is going to engage things like class validator to check to make sure that the input is correct. And then I set up my GraphQL helper. This is another test helper. This comes from Castor Utils test GraphQL. And this is what makes it really easy to use GraphQL calls with supertest. So I'm passing the app.getHTTP server instance into this GraphQL tool. And so let's pull this up and see what it looks like. It's not too complicated, really. It's just this function here called query. And query takes the actual query document. So you'll see down here, I'm defining the query document like this is my get current user query. So it takes the document, it takes the variables that you want to invoke the query with, and it can be a mutation too. The word query is, you can see there's an alias down here for .mutation, which is really just this .query, but another name for it. It's all semantic. But then it checks to see if there's a token, and if so, it sets the authorization header with the contents of that token. So it's actually passing it through in the authorization header in the request that it makes to the service that's running behind the scenes. And that's what supertest does. Supertest actually takes the HTTP server instance. It's not started up yet. Supertest will start it up behind the scenes. So it manages the application process itself. And then it also allows you to issue requests to the application process that it's managing and then check values on the result. So when you call query here, it adds the token. It uses, what is this? This is, oh yes, this is supertest. It uses the .send method on supertest with the query and the variables. And then it checks to see if there are errors. And you can turn that functionality off. You can say warn false if you don't want to do a console log about the errors, but it's often really useful to do that, especially if you're not expecting an error on this call. I'll typically only turn warn off when I'm testing an error and I expect it to happen. So It'll check to make sure the status code is what you expect. And so the end result that you get is a really clean GraphQL query call right here. So this is my first test that I'm in the middle of. You can see before all the tests, we create our test user based on the user input that we set up. And then after each test, we try to delete the user in case it exists, and then catch it and pass if it doesn't, because there are certain tests where the user doesn't end up being created because we're testing an error scenario. So we don't want that to fail the tests. So it retrieves, so this first test here for, what am I describing? The get current user query. It retrieves the currently authenticated user. This is the test where we were just passing in our dummy user in the unit tests. But now here, it's doing all the work. It's got the guard middleware engaged. It's got the decorator working for us to pull the user object. So in this case, it's actually doing all the work to take the sub off the token and look for the user matching the sub in the database, and then populating that for the method. You saw how simple the method was, but here's it actually doing its work. So we call GraphQL query, we tell it which query we're calling so that it can do some type checking for us, and then we give it the token as our parameter, which token we want to use. So this is where you can put the alt token in instead of the main token to test other users. And then you're checking to see if the data that came back from the GraphQL query is correct. So this actually fires an HTTP request. It actually goes out to the database. It actually hydrates all the objects from Prisma and everything. And it's a really good, almost end-to-end test to make sure that when a front end calls your application, it's working the way that you expect it to. You'll see here, this is one of my negative tests, it requires authentication test. And so in that case, you'll see I'm not passing a token, but I am telling it not to warn on an error because I'm expecting an error here. And so this is what I expect my error to look like. It should have this unauthorized message. It should have code unauthenticated. It should have status code 401. And so, yeah, this is generally how I'm working with integration tests on the GraphQL front. Now, I haven't actually run these tests today, so I hope they're working. If not, you'll get to see a quick troubleshooting session. But let's go ahead and run. Let's see. I'll just do them all. Yarn integration. Fingers crossed, YOLO. Let's see if this works. It's entirely possible that I've forgotten to run the database migrations too, in which case it'll fail miserably. No, it's working. I mean, yes, it's working. So everything looks to be fitting together correctly here. It's already passed all of the episodes integrations tests. So for each operation, I'm invoking it multiple times, doing all the different things that I expect it to do and testing all the rejections that I expect it to reject. And then you see this special test here, events.integration. I'm actually spinning up WebSocket events and emitting events and making sure that they're handled correctly too. That's something that we'll go into in a later video. All right, so now you can see the integration tests working together. This is hitting the database that's running on my Docker Compose stack behind the scenes. You'll see in the package JSON, there is a script. Where it is, yes, there's my Docker API here. So this is how I'm running Docker Compose behind the scenes. That's the API dependencies, and then if you want to run the app too, it's here, which is useful sometimes when you're testing the Docker build itself. Oh, there we go, yep. 45 seconds, that's not bad for an integration test run. They take a whole lot longer than the unit test because they're spinning up everything and running through all the paces. All right, so that was a lot of stuff to go through all at once. Hopefully that's been helpful though. The unit and integration tests are the primary ways that I make sure that my API is working the way that I expect it to. But there also is the matter of end-to-end testing. And so I mentioned that there were some frameworks out there for native apps too. So I put those on the slide, and I didn't put the Cypress and Selenium on the slide, but just know for the web ecosystem, Selenium is the old faithful, Cypress is the the new kid on the block that's made a lot of headway. And then there are some new school tools that are popping up too that kind of handle some of the shortcomings of both of those tools also. If you've ever worked with either of them, they can be quite frustrating. Then when you get into the native app or the mobile side of things, Detox and Appium are both projects that will test not just React Native, but other types of native apps, purely native apps as well. It doesn't have to be like a web-based framework, right, like React Native is. But there are definitely ways to test. But like I said, those are cases where you have a front-end application. In our context, we don't in this case. All right. Well, thank you for bearing with me through this. And sorry about the delay between the last episode and this one. I'll definitely be continuing this series, but I'm also taking a pretty hard look at Rust, and I'm really excited about it so far. It challenges some of the assumptions that I've had around sound type systems and healthy kind of strategies or flows or styles to use. I've typically avoided a more imperative style and went with a more functional or point-free style. And I can see how that is harder to work with often when you go with the point-free style where everything just tightly fits together and everything is very compressed and tight. It can be really hard to read, and it can be really hard to debug specific parts of a function. And so I like the imperative style of something like Rust, especially because it provides a lot of safety, a lot of guarantees. It gives you a lot of the features of a high-level language, but it allows you to work in this more familiar kind of imperative style that you'll see that you've seen in TypeScript and other languages, and I'm really liking it. I'm excited about it. So I'll be moving on to Rest as my next video, or Rust as my next video series, definitely. And if you're interested, I've got another GitHub repository that I'll link here that I'm in progress on, trying to find the same kind of strategies that I'm using in this Nest.js project, but in a Rust context with their powerful memory safety and their high performance kind of zero runtime model. It's pretty cool stuff. If you haven't looked at Rust yet, I think that's going to be my future stack that I'll be shifting into over time. So anyway, thanks for hanging out with me, and I hope you will have a great holiday season. I'll probably be able to get another video out before the end of the year, but if not, enjoy your holiday season, and I hope you have a happy new year. Thanks a lot.